Hello, dear students. I'm happy to teach you this course. The course will be about Calculus 1. In this course, you are learn about many mathematics concepts like domain, range, integral, and many things. So here, really, it's like a review for your last class, which is 12. So in this course, there is no many new idea here. Just really you will advance in your high school. So first of all, we are going to start with the function. Talking about the function in this section, and the very important things here is the function and their graph. So how's the function, how we find the function, how we define the function. That's the first of all. The second is about the domain and range, which they are very important in your course, because the domain and range will let you know many things about the function. So I'm going to start directly in the definition of a function. Let's say that if you have a function f, like here we have a f and we have an input and output. So f is like a factory. We will put any things. For example, we will put a tomato and a can, and then we will get pure tomato. So that's all. Like f is like a function, is working as a function. So that's all. That's all like a factory. That's all the about the story of the about function. And here's the domain, and also we have a codomain and range. Now for example, the example 1, we are going to teach about the example 1. In this example, y is equal to y, or sometimes we say f of x, means that when I say y or f of x, they are both are equal. So in the function, usually we are using the f of x, because it means that f is the output and x is the input. And see here's the x-axis. So when I say what's the domain means that which value we can, or domain or input. When I say domain, it means this line. It means that which value we can take it from here. For example, 1, 2, 3, anything. When I say y-axis, we mean f of x, or range, or you can also sometimes call codomain. That's all. So the value of y will give us the value of the range. That's very important. So from now, the x-axis is domain and y-axis is the range. And for example, if I say y is equal to x square, or f of x equal to x square, if you know the function, how to sketch it's okay. Otherwise, we will teach you and I will give you the many examples, or I will review it during the QA session. So here's the function of the graph of the f of x is equal to x squared. Now you can see in your page 1, he asked you about, or it's asked about the domain and the range, how we can find. When I say the domain, means that if f of x is equal to something is equal to x squared. So just let me know in the x-axis, can I put 0 here? Yes. So 0 is in our domain. Okay, it belongs to our domain. So now I'm asking myself, it's easy, or it's okay if I put 1 here. Yeah, 1, 2, 3, 4, 0.5 square root of 2. It's okay. I put the value here. So if this is possible, you can say yes. So R positive are also in our domain. R positive means that from 0.0001 till infinity. Okay, so means that R positive. How about R negative? R negative means that 0.000 from negative to minus infinity. So that's all about all R positive and negative. How about the value? Can I put, for example, -2 to my function here? It's okay or not? Yeah, it's okay. So I can put -2 here. So this is also belong to. How about minus a square root of 3? It's okay. I put here. Yes, it's okay. So also I can say what? I can say 0, positive, negative. So that's why I can say from the negative means that this is over x-axis. You can put negative value and 0 and positive value. So that's why we write down like a this sign, like a parenthesis. This parenthesis will be called as a open interval. Okay, so we have an interval. Here's open interval, means that 1 and 2, but they are not include. This is the closed interval, so means that we have 1 and 2, but they are include. We will fill the gap. We will leave it as a whole. Also, we have a clopen or half open and close, so means that 1 is exclude and 2 is include. So when I say 1 and 2 is include or exclude, when I say 2 means that exactly 2 here, but when I say 2 here means that 1.999 here, but there is no 2. So here is no 2. How about here? Yes. How about here? Yes. How about E1? The same. Also, we have another, maybe in your high school, you have this one. Okay, this one. So both are equal, are equivalent. Okay, these signs are equivalent. When we say open, you can write down like that or write like that. When you see close, it should be like that. Okay, how about another side? This one is closed and to be open, it be like that or like that. So okay, or like that. So means that we have 1, 2, but 1 is include. Yes, we have 1, exactly, you have a 1. How about 2? No, we have 199. There is no 2 because you have open, close, open and close. So that's why I say the interval, the domain here, the domain of the function is equal to what? The domain of the function is equal to negative infinity to infinity. So here's, you should think about the domain. Really, that's not enough for you to just exercise or just think about these 5 examples. No, you need more and more. So for that purpose, I'm recommending you to study the really the exercises. Okay, so how about the range? Y is equal to x squared. The domain of function is equal to minus infinity and infinity. How about the range of function? This is the symbol for domain and this is the symbol for the range of function. How about the range? The range means that, look, here's the graph. The range means that the shadow over y-axis. So here's a 0, here's 1, 2, 3, 4, 5, square root 2. So the shadow of the function can be followed over all the y-axis. No. It should be, it's okay to be 0, it's okay to be positive, but there is no negative. There is no negative. That's why I say the function, the range of the function will start from 0 to positive infinity. That's why we have this one. Now I'm repeating this one again, this example, because really very, very important. In case you know the graph, it's very easy for you. Why? Because I say x squared. So here's the picture of the x squared. Okay. So the shadow of the x-axis is my domain. Look, I can put the shadow. So positive, 0, negative. So the shadow of the function over x-axis is my domain. So I say minus infinity to infinity. How about the other part? The shadow over y-axis is my what? Is my range. Look, here's the shadow. Here's the shadow. How about here? No. How about 0? Yes. How about minus? No. So that's why I say the range of function is equal to what? Will start from 0 to positive infinity. That's really very important in case you know the graph. If you don't know the graph, let me ask myself. I don't know the graph. Y is equal to x squared is like that. So I don't know the graph. It's equal to what? So in that case, you need more thinking about the value, because the value, say f of x is equal to x squared. Okay. Can I put the 0 here? Yes. Can I put the negative here? Yes. Can I put because sometimes you cannot put any numbers, all numbers. I will give you another example later. Or we have also in the second example. So can I put 0? Yes. My negative, positive? Yes. So that's all. So it means that you can put everything. How about here? If I put 0, I get what? You get 0. If I put 1, I get what? 1 square. Okay. If I put 0.5, I will get what? So I get 2. Sorry. If I put a square root of 2, I get 2. What? I get 2 because square root f of square root is equal to square root square, which is equal to 2. So there's no problem. How about minus? If I put minus square root, for example, I get what? I get minus square, which is equal to 2. So it means that there is no negative. Positive from 0 to 0 to positive. So there is no negative. The output, there is no negative. In that case, means that I will get 0, also positive. So in all these cases, this is my range, okay, without without sketching the graph. So really you need more and more exercise. That's why I say please, for the domain and range, it's not easy. Even sometimes I cannot find the range without thinking. So please, you should think about domain and range. Now I'm going to the next example. You will be, if you are with me, you can find something. Here's the graph. In case you know the graph, especially the basic graphs, and you can see the shadow of here is everything just except 0. So a 0 is excluded. So that's why I say negative infinity till 0. There is no 0, open 0, union 0 to positive. Or maybe the other student write all real number. This is the symbol of the real number, all real number without 0. Both are equal. These one both are equivalent, because in this case I say all negative value without 0 addition without 0 to positive. So that's what means that the shadow, just there's everywhere shadow of the x-axis with excluding the 0. How about the range? You are telling me. Think about it. Think about it. You have a range. How about the range? No, the range, no, there's just something else. No, they are the same. So there's no 0, negative, positive. Look, and there is no 0. So the same range, this is the domain of function, and this is the range of function. Look at the difference, r, f, r double, like that. Means a real number without 0, or you can write down like that, okay, as in did it in your book. Okay, now I'm going to square root of s. Even I know the graph, but I will leave the graph for you. Why? Because I say just let be thinking about without graph, thinking about the domain and range without graph. In that case, I say I can put which number to here. Can I put positive? Yes. Any positive? Yes, any positive. Even square root? Even square root. It's okay. When I say even square root, I mean something like that. It's okay? Yes, it's okay. Okay. How about 0? Can I put 0? It's okay? Yes, also okay. Why? Square root of 0 is equal to 0. So it means that's okay. How about negative? Can I put minus 2 for here? No, you cannot. So that's why I say the domain of the function, this function, the second one, which is equal to square root of x square root, so is equal to 0 to infinity. So I can select value for here to here exactly. You can put all here to there. How about negative? There is no negative. Okay. Okay, if I put 0, let's start. If I put 0 in my factory, I get what? F of x is equal to square root. If I put 0 here, I get what? 0. So 0 is output. If I put 1, 2, 3, 4, 5, 6, 7, I get what? Positive value, right? I don't care about what's value I get, but I get in general I get positive, right or not? Is there any negative in output? No, surely no, because the square root never will take the 0 negative here, and also he cannot, or it cannot give you the negative value. That's why I say I have also positive, and so this is the range of function. So both are equal, the domain and range. So how about the next example? I'm going to another example. How about 4 minus? Without knowing any graph, without sketching any graph. How about, but don't forget, just be in your imaginary, say x-axis is my domain, it's equal to input, and y-axis is my range, which means that output, means that what's the result, output. Okay. So here, can I put 0 here? Yes. Can I put, for example, 2? Yes, why not? Can I put 4? Yes. How about 5? How about 5? Can I put 5 here? No. Why? Because the result is equal to minus 1. So let me decrease this one. I can put 4, 0, 1, 2, 3. How about 4? Yes. All of them is okay. Because minus 0, minus 1, minus 2, minus 3, and 4. Okay. And the square root are okay. How about 4.1? Can I put 4.1? Check it. 4 minus 4.1, which is equal to minus 0.1, which is forbidden. We cannot put it. Why? Because we will get negative value under the square root, which is not allowed. So in that case, this is my domain. This is my domain from 4. My domain will start from 4. Okay, we cannot put more than 4. We cannot put more than 4. How about 4? So okay, how about more than 4? There is no 0.001. Even you cannot put 0.0001 because you will get negative 0.0001 under the square root. It's again not allowed. So now my upper limit is 4. How about the decreasing numbers? We put 4. How about minus 2? Can I put minus 2 here? Check it. Check it. I don't know. 4 minus 2. Yes, why not? Because this minus will multiply by this minus and will give me the positive. So means that I can put minus 2, minus 3, minus 4, minus any number. So that's why I can put all the negative value. This is my what? This is my domain. Why? Because I ask it, can I put here? Can I input here? Can I put this one? Yes. So that's why we can say the domain of the function will start with all negative till number 4. If we are exceeding number 4, you will get the forbidden number. You will get the wrong number. That's why. Okay. How about the range? The range of the absolute square root always is what? 0 to positive. Okay. Okay. Why? Because here. Okay. Because here, at least we'll start with the positive. Because here, if I put this is not in general, just we'll change for the case. Go next, we will see the different. Sorry, in the next example, you will see the difference between the examples, and we'll give you then another number. So in that case, so if I put any negative number, I will get what? I put any negative number here, I will get positive. How about if I put 4, I will get 0. So means that what? Means that the range of function will start from 0 to infinity. Why? Because I put every my input, every tomato that I have, I put it here, and this is my pure tomato. This is the result. Okay, I inputted anything that I have. For example, I gave 4, I got 0. I gave 3, I get positive 1. I get any. So that's why I will write that one. This is the before the last example. This is the example number 4 in the example 1, but fourth part. How about y is equal? This is very, very important because this is this example will give you more difficulty, will give you more thinking. You need more focusing, more concentrating. So be with me, please. Do not feel any just think about the number. So can I put which number I can put it here? Can I put 0? Yes. Can I put 0.5? Yes. Can I put 2? No. Why? If I put 2, I will get what? I'll get 1 minus 4 is equal to minus 3. 1 minus 4 is equal to 2 squared is equal to minus 3. So it's not allowed. So the 2 is not allowed. How about smaller, between 2 and 1? Let me check from 0. We check it, this one. How about 0.5 to say, okay. How about 1? If I put 1, 1 minus 1 is equal to what? It's equal to 0. So it's okay. That's the result is 0. Just the dangerous number was negative under the square root. Okay. So for what is okay. Now I'm going to less than 0. For example, if I put minus 0.5, see, it's okay? Yes. Why? Because I will get 1 minus 0.5 squared, which is equal to 1 minus 0.5 multiplied by 0.25. So it's equal to 0.75. So it's a positive number. It's okay. So good. How about minus 1? Let me check. 1 minus 1 square. I'll get what? I will get 1 minus 1, is equal to 0. So okay, how about if I put more than minus 1? I put 1 point minus 2, for example. If I put 1 more than 1, I'll put minus 2 square. I'll get what? I will get 1 minus 4 is equal to minus 3. Also again negative, so I cannot exceed 0 even more than minus 1 by 1 point. So that's why I cannot put any value more than this. So my domain will be bounded by minus 1 and 1. Why? Because if I give more than 1, I will get the negative value. If I put the negative 1, more than negative 1, I will also get negative value. How about the range of function? Okay, you tell me. That's why I say you should think about it. You cannot imagine everywhere, and don't say it's equal to 0 to infinity. No, who say that? I said put here and see the result, your output. Put the tomato and the can and see what you will get. Maybe the factory is not working properly. So I say if I put 1, here's your input. If I put minus 1, I will get what? If I put minus 1, I will get 0. How about if I put 0, I will get what? I will get 1. How about if I put 1, I will get what? Again, I will put the zeros. That's why your range will be bounded, enclosed by between 0 and 1. That's all about the domain and range. And here's your solution. Here's the all the writing here is about the token that I taught you now about the how solving this one. Even though you can, if there's another way, and please do not hesitate if you are solving the domain or find the domain by any way. It's okay for me. Even for any question, you can use by your any method. Just be let be the right. For the domain, we have a trick or we have a knot. For the domain, if we have square root, for example, I have a square root 4 minus x. Okay. For finding domain, okay, you can see directly minus 4 is greater than or equal to 0. Okay. And then you can say that for x, so which means that x less than or equal to 0 means that here's 4 less than 4. So this is your domain of function as we did it before in the next. Also, anyway, you can use that one. This is about the page number 1, and in this section really we have like a review of the example. That's why he gave you the domain. And how now here in the page number 2 there's a definition of the graph. What's a graph? He say that the graph is putting x and f of x together, then you will get the point, right? For example, I will give you, I say f of x is equal to, as we have here, x plus 2. So if I put 1, I get what? I will get 1 plus 2 is equal to 3. So I get 3. So 1 and 3, where's 1 and 3? Here's 1, 1, 2, 3. Here's the point. Okay, 1 over x-axis and 3 over y-axis. So that's why this point will be 1 and 3. How about the graph? The graph is the collection of these points. That's why he say the collection of these points where the points, the x are belong to D. What do you mean by D? D is the domain. So here's just the graph. Okay, dear? That's the really a shortcut for the graph. And here's the test for you. If I, for example, I give you the picture, 2 pictures or 3 pictures. I have this one, and I have this one, and I have that one. So let me know what do you call by this one? Which of them the function? Which of them does the graph? All of them, they are the graph. Why? Because you have a point, x and y, x and y, x and y, x and y, x and y. So that's why all of them, they are graph. Okay, so for the graph, yes, G, yes, G means that graph, yes, we have a graph. How about function? No. For the function, we have a test, as he called what? As he called vertical line test. Vertical line test means that you are sketching the line like that, vertically, like a pen. So in that case, if the intersection point is just one point in that graph, you will say it's a function. So this is a function, yes. How about this if? Here's the vertical line. We have 2 points instead of 1 point. So that's why we say it's not graph. It's not function. So it's a graph. How about this one again? Yes, this is not function. Why? Because you have a two intersection. That's why in that case we say we have the graph. In case we have any graph and we say function, if in case that the vertical line test is just intersected in one point. That's all about page number 2. As I told you, this is like a review. Here's the thing till here. Okay, now it's time for what? The time for example 4 with the absolute value and the greatest integer. We will leave the greatest integer as no, I'll tell you also, but the graph I will let you know later. And also we are going to talk about this type of the graph. Okay, dear. In absolute value, when we say on page 3, your lecture note, okay, we have an absolute value of x. When I say absolute value, it means that we have an x, and there's two possibility of x be positive or x be negative, because we are inside of the absolute value. Inside of the absolute value, for example, you have 2, you say is equal to. How about if it's minus 2? Also, you can say 2. So in that case, we say is equal to x. In case x greater than or equal to 0, means that. And also we can say the real value was minus in case is less than 0. That's all. Okay, how about the graph? The graph, we say there's the graph of x. Okay, y is equal to x. This is the graph of y is equal to what? Y is equal to minus x. I will really review for you the more basic examples here. So in that case, when you have two mixed things, okay, we recalled in the function if f of x is equal to one part, it's okay. But if f of x is equal to 2 or more than 2 parts, we recall as piecewise function. Okay, piecewise function. Piecewise function. Okay, dear. In that case, if you have a piecewise function, here's the piecewise really together. Piecewise function. In that case, we have a piecewise function. We should follow here. Okay. And the easy things in the piecewise function is what? In the piecewise function, for example, we mean about the function to be sorry. Directly, the user or the teacher gave you the domain. Here's the domain. How? Because we have what? Sorry. We say in that case, x greater than or equal to 0. Huh. How about that case? Union x less than 0. So what do you get? We get that here's the 0. Include to infinity. How about that part? Means that exclude to minus infinity. So in case if you are C, we have a domain. Okay. For example, if I give you the f of x is equal to x minus 2, 3, x greater than or equal to 3, let me say x just greater than 3, x between 3 and 4, x greater than so we say x is equal to x less than 4, x 4 less than 5, so x greater than 1. Look, now you should give me the domain directly. How? By this one. I say I have 1, okay, 3, 4, 5. Okay, so greater than 1 means that open, because there is no equality. If I have equality, we should fill the gap. Okay, now greater than, this is here. How about x between, okay, x between 3 and 4. Here's, how about x less than 5? So here's the domain that you have. I can say from 1 to 3, and I close the 3. Why? Because there's a clause here. And union, look, 3, 4, union 4 to 5. That's all that I have. Okay, no more. In case we have a equality here, we will say 4 to here, 4 to here. That's all that I want to say. Now I'm giving you a real example. Example 4. Here's the domain. Tell me about the domain. Look. F of x is equal to minus x, x square 1, and x less than 0, x between 1 and 0, so x greater than 1. Now tell me about the domain, d of f, no more. Now about the domain, I say here's 0, here's 1, okay, less than 1, 0, sorry, here's less than 0, means that from 0 to minus infinity, that's why I'm sketching like that. Between 0 and 1, and both of them, they are include, so I say between 0 and 1, and greater than 0. Greater than 0, here's the greater than 0. Now, you should tell me, the domain is equal to what? The domain is equal to, okay, from infinity to minus infinity. Why? Because here's minus infinity, and come to infinity. If you mention 1 and 2, you don't need it, 0 and 1, because also they are included here. Okay, so it means that 5 here, 10 here, any other numbers here. So that's about the domain. How about the range? The range, we should put 0 to here, and 0 and 1 to here, and 1 to here. Now, this is the first important thing in the piecewise function. How about the graph? Also is very important. Before I'm sketching this one, I'm going back to this one. I will remembering you many idea about the basic graphs. What do you mean by the basic graphs? I think there's a basic here. Let me see. Yeah, that's exactly what I want to give you. In the page number 5. Here's the page number 5. Pay attention in this page, and you will see there are many basic examples, and you are familiar with it, and you know what I mean. Okay, why I say it's familiar with you? Because you saw this example many times. Here's what I'm drawing for you as a review. Okay. Page number 5. Review it, please. It's necessary. When I say y is equal to x, means that we have like that. When I say y is equal to x square, you can say it's like u. When I say x to the power 3, the line is like n. When I say power 4, is again like that. Don't say w, because if you have a w, means that you have x power 4 plus something else. When you have x to the power 5, means that the same shape but with a little bit wide here. So don't care about the wide, so it's the shape. You are caring about the shape. Really, it's the shape